Hi class, this is our second lesson. Now we'll be discussing dynamics. I've already introduced dynamics in the class, not much. Let's continue. Okay, this is exercise 4C in your textbook. Okay, see the question says in each scenario the forces acting on the body causes it to accelerate as shown. Now there is the example 5a here. There is an object 2 kg. Definitely the weight will act downwards and there will be a reaction force as we discussed in the class, and it is accelerating in the upward direction. Let us take this slide. Okay, so this is the scenario. Remember, in the whole, there are three chapters now. Dynamics basically is divided into three chapters in your books, in your textbook. Chapter 4, 5 and 6, you'll be doing the same thing again and again. Because the object is accelerating, we'll be using the formula for acceleration, force of acceleration, F equals to ma, where remember F here will be the resultant force. Now every time you have to, when you're doing this in the exam also, you have to write this, that you're resolving upward as positive direction. Okay, so in this diagram, because the object is accelerating up, we'll take upward force as positive, so downward will become negative. Hence so again F equals to ma is the main equation in this chapter of dynamics. So where F is your resultant force basically. So now because the object is moving upwards, the P becomes positive, 2g becomes negative. So the resultant force is P minus 2g, and ma, mass is given to us 2 kg here, and acceleration is written here for us 3. So we substitute, that's it. When you solve simple mathematics, you get the force P is 25.6 Newton. That's it. Again, let us talk about question 5b now. You say, see the same thing. Because the object is moving downwards, we resolve down as positive, and the same formula. So this is the resultant force equal to mass into acceleration. Same, F equals to ma. Because it is going downwards, 4g is positive, 10 is positive, P will be negative. So resultant force equal to mass into acceleration. Simple mathematics will give you the magnitude of the force P. Let's go to the new slide. Now, same, in each scenario the forces acting on the body causes it to accelerate. Again, an accelerating body, F equals to ma. Let us take 7b. So if I again, because the object is going up, here see in this example forces are given, acceleration is missing. The same simple mathematics. If I resolve upward as positive, and same F equals to ma, this is the resultant force. So because it's upward is positive, 100 will be positive 8g. Again, some student think g is gram there. It's not grams. It's a formula for weight, mass into gravity. So g is 9.8. So it's 100 minus 8 times 9.8 equals to mass into acceleration. Again, simple mathematics will give you the acceleration of this body. Okay, let's move on. Now this example, I think let's take a pause. Try to pause this video, go through this question and see if you can do it. So pause the video now and then you can continue with me. Okay, I hope you tried already. Let us take a look at this question. The question says the lift of mass 500 kg is lowered, okay, or raised by means of a metal cable attached to its top. The lift contained passenger. Okay, there's a passenger whose mass is 300 kg. The lift start from rest. See, now whenever you see something like this, they're going into kinematics. Starts from rest, so they're giving you initial velocity is 0, and accelerate at constant rate. So there is a constant acceleration a, reaching to a speed. So now final velocity u is given. So and the displacement s is given. So we just use a simple kinematic equation here. We know u, we know v, we know s. We put in this formula and that gives me the acceleration, and we answered part A of the question. Now for part B, we'll use the same F equals to ma concept. Now look at this scenario now. Because the mass of the lift was 500 and there's 300 kg passengers inside, the total mass becomes 800. So the weight will be 800 into 9.8, 800 gravity, 800 g. And let us take in 9b, it is going downward. So we'll take downward as positive. And we know acceleration is 0.9. So this is 0.9. Again, we'll resolve downward as positive. Same formula. F equals to ma. Resultant force is mass into acceleration. Resultant force 800 g minus t is mass into acceleration. Simple mathematics gives you the tension. Part C, I'm leaving it for you to do it. Same thing, just change the direction and try to find it. Let's go to the next slide. Okay. Again, try to pause here, pause your video, try to solve on your own, and then I'll continue. Okay. A trolley of mass 50 kg is pulled from rest in a straight line, whatever, horizontal rope, this and that. Okay, the trolley accelerates at a constant rate and after 2 seconds, the speed, see again it starts from rest, so u is 0. After 2 seconds, t is given velocity, the final velocity is one simple kinematic situation. You put in this formula, you get the acceleration. That is the answer for part A. Part B, again, if I just make a simple scenario here, the object is, the mass is 50 kg, okay, and this, let us take this as t, 20 gram, 20 Newton, the resistance C, it moves, the trolley experience a resistance to the motion. So if I am assuming that the object is going in this direction, look at the arrow, definitely resistance will be opposing it. That's why the resistance in the opposite direction, and our job is to find the force here. Same, F equals to ma. This is the resultant force equal to mass multiplied by acceleration. Because the object is going right, we'll resolve right as positive, so t is positive, 20 negative, simple mathematics. You get the tension in the rope. Next, now see, this is the same thing we studied in vectors already. I would like you to do it on your own. So this question is your task, you will do on your own. Let's go to the next slide. Okay, two forces, this and this, act on a particle. The resultant of the two forces is R. Okay, there are two forces acting, the resultant is R. Given that R act in direction parallel to this, again the same concept we did in vectors. Parallel, we studied parallel vector means if one vector is the scalar multiple of the other. So let us see this question. So resultant force is just the sum of the two forces. So R is this plus this. I just took I component and J component separate. This force R is parallel to this. Remember, parallel means scalar multiple. That's why I took a K. So all of this equal to K times the other vector here. Okay, K is any scalar. And now you open the bracket and you know that now we can take the I component separate, the J component separate. See, if I compare the I component, this I component 2 plus P equals to this I component minus K. Comparing the J component is 3 plus Q here. The J component here is 4K. I compare, and now because they want us to prove that this gives us 4P plus Q plus 11 equals to 0, you just try to solve them simultaneously. What I did is from 1, in place of K, I can write minus 2 minus P. This is what I did. K equals to minus 2 minus P. You simplify, you get the answer. Proved. Let's go to the next slide. Again, this is something we studied in vectors. We just did the previous question. This is again your second task. Try to do it. And if there's any doubt, we'll discuss in the group. That's it. This is for the lesson number 2. Inshallah, I'll come up with the third lesson soon. Goodbye.